Hi, I'm Braden.
I'm Pawnee.
If we're asked to analyze a sample from a normal population by conducting a significance test for the population mean, but we don't know the population standard deviation, which is pretty common, we will use a one-sample t-test of significance rather than a z-test.
In a match pairs design, you match up similar people or match up people with themselves in an experiment in order to see the effect of treatments on similar or identical subjects. Remember that when using this design, this is only representing one sample for one population, so you will still use a one-sample t-test.
Police trainees were seated in a darkened room facing a projector screen. 10 different license plates were projected on the screen, one at a time for 5 seconds each, separated by 15-second intervals. After the last 15-second interval, the lights were turned on and the police trainees were asked to write down as many of the 10 license plate numbers as possible, in any order at all. A random sample of 15 trainees who took this test were then given a week-long memory training course. They were then retested. The results are shown in the table below. Test at the 5% level of significance that the memory course improved the ability of the trainees to correctly identify the plates. Here we see column A, the number of plates correctly identified after training, and column B, the number of plates correctly identified before training. By subtracting column B from column A, we can find the increase in license plates correctly identified for each of the 15 trainees after the memory training. Using the difference column, we can now perform a significance test to determine if the memory training course was actually effective.
First, identify the population as all police trainees. Next, identify the parameter as the mean difference mu in license plates correctly remembered after the memory training course. The null hypothesis is that mu equals 0. There is no difference in the number of license plates correctly remembered after the memory training course. The alternative hypothesis is that mu is greater than 0. The number of license plates correctly remembered after the memory training course is increased from the number correctly remembered before the course.
Next, we will choose the test we are going to use and verify that the conditions are met. Because we are analyzing a matched pairs experiment, and we do not know the population standard deviation, we will use a one-sample t-test for the population mean.
The conditions are 1. Random. We are given an SRS in the problem. 2. Normal. The normal probability plot of the data is linear, which means the data can be treated as normal. 3. Independent. The population is greater than or equal to 10 times the sample size. The number of all police trainees is greater than 10 times the sample size of 15, or 150.
Next, we calculate the test. Firstly, the mean of the difference column, x bar, is 1.5333. Using that number, we can then use the standard deviation formula to calculate the sample standard deviation for the difference column, which is 2.1996. Using those numbers, we can then calculate the test statistic, starting with the general formula test statistic equals statistic minus parameter over the standard error of the statistic. In this case, the t-statistic is equal to x bar minus mu over the sample standard deviation divided by the square root of n, or sample size. One big difference in the t-test from the z-test is seen here, where the population standard deviation is substituted for the sample standard deviation divided by the square root of the sample size, or also known as the standard error of the sample mean. So assuming the null hypothesis is true, we plug in 0 for mu, and then plug in 1.5333 for x bar and 2.1996 for the standard deviation as calculated before, and we use 15 for the sample size, of course, thus calculating the t-statistic to be 2.7. Then we calculate the degrees of freedom, which is n-1 for a one-sample t-test. 15 minus 1 is 14, so our degrees of freedom is 14. Using the t-statistic and the degrees of freedom that we found, we can find p either using a method on the calculator or using a t-distribution chart. Thus, the p-value is found to be 0.0086, indicating that it is unlikely that the observed statistic occurred by chance. And now to interpret the results that we calculated. With such a low p-value, 0.0086, we reject the null hypothesis at the 5% level of significance. Evidence suggests that the memory training course statistically significantly increases the number of license plates that a trainee can correctly remember.